Today we're going to cover Chapter 3, Section 5. Today we're going to learn how to find and use slopes of lines. So the first thing we're going to do is define slope. And the slope of a non-vertical line is the ratio of the change in y, the vertical change, to the change in x, the horizontal change. So you're going to be given two order pairs. And just like before with the distance formula, you'll have your x1, y1 and your x2, y2, and then you're going to plug them into this formula. You subtract the y's, and then you subtract the x's, and then you'll simplify the fraction. Now, slope is also defined as rise over the run. Now, you're always going to see slope indicated as a lowercase letter m. So if you're given a graph, you could count if it's nice and organized on graph paper and you look at the scale of how the numbers go up. You can also count the squares for the rise and then count the squares for the run. But sometimes it's easier to use the order pairs because a lot of times if you count the rise and the run, sometimes you may forget if the line is falling from left to right, if it's negative. The biggest mistake I see when students are doing the slope formula is they forget that the y's go in the numerator and the x's in the denominator. And when you're given the order pairs, it won't matter which order pair is x1, y1 and which one is x2, y2. You'll get the same answer just as long as you stay consistent. Now, a little trick, I don't know if this will help you, but again, this is the most common mistake I see is students think that they have to subtract the x's in the numerator, but the x's go in the denominator. So a couple years ago, a student of mine said that his middle school teacher taught him a story to help him remember that the y's go in the numerator. So the teacher told him that you were going to go on a picnic and you were having a picnic on the side of a mountain, and a mountain has a slope to it. So on the side of this mountain, you wanted to set up a picnic table. So I'm going to build my picnic table, and the x's become the legs of the picnic table. So this is my table, and at that picnic, I'm going to be serving some yum yum juice. I'm just making up something that begins with the letter Y. So I'm going to put my yum yum juice in my glasses that look like a Y. And then just remember that you subtract the y's in the numerator and you subtract the x's in the denominator. And again, you could put your little subscripts to, you'll put 2 here and 1 and 2 and 1. So these are different types of slope. So when your line rises from left to right, it's going to end up with a positive number. There'll be a positive slope. When it falls from left to right, it'll have a negative number, so it'll be a negative slope. When the line that is graphed is horizontal, this will have a slope of 0. Now, when you're given an equation, the 0 slope line, or the horizontal equation, is just going to be the equation with y equals a number. So let's say I told you that this was at the number 2 here. So let's say this is 1 and 2. This line that's graphed would be the equation y equals 2. And then let's say you did the slope formula, the y2 minus the y1 over x2 minus x1. Let's say we picked 2 order pairs that were on this line. Let's say I picked the order pair 0, 2. And then let's say I picked another one here. Let's say it's 2, 2. And then if I subtract these and I do 2 minus 2 for my y's and then 2 minus 0, notice what's ending up when I do the formula is my numerator is a 0, but my denominator will be a number. And whenever there's a 0 in the numerator, this will simplify to just 0. So this is what's going to happen is in your problem, the 2 order pairs, the y value will be the same. And then that's how we can get y equals 2. When the graph is a vertical line, then the slope is undefined. So let's say on this one, I told you that this one was same thing. Let's say it's x equals 2. Let's say this is 1, and then it's hitting here at 2. So let's pick 2 points that are on this line. So let's say 2, 0. And let me go up a little higher. Let's do a different number. Let's say this order pair is 2, 3. Notice what's the same this time are your x values. This equation that's graphed is going to be x equals a number, and it is the number where your line crosses through that x-axis. So again, if I did the slope formula, then I would be doing 3 minus 3 over, 3 minus 0 over 2 minus 2. Notice this time the zero's in the denominator. If I give you a question like this on the test, I don't want you to leave it like that. I want you to tell me that this simplifies to undefined. Same thing on this one. When the zero's in the numerator, I want you to show me it simplifies to 0. Now, a little trick here. Whenever you see that your line is vertical, if you think about it, it looks like your line is going up and down. And then if you take the U and the N and the D, the first letter or the middle letter from and it looks like it's starting to spell undefined. So if you look at a graph and you see it's up and down, then you know your slope is undefined. If it's a horizontal line, it's a flat line. There's no incline to it, so the slope is 0. So we have a theorem, and it's called the slopes of parallel lines. So in a coordinate plane, 2 distinct non-vertical lines are parallel. Notice the words if and only if, so it could go either way. They have the same slope. So whenever you're given 2 lines and you want to determine if those lines are parallel, you are going to calculate the slope using the slope formula and see if you get the same number. So parallel lines have the same slope. Whenever there are 2 vertical lines, they will always be parallel. The theorem for the slopes of perpendicular lines states that in a coordinate plane, 2 non-vertical lines are perpendicular if and only if the product of their slopes is -1. So in other words, the slopes are going to be opposite reciprocals to each other. Horizontal lines are always perpendicular to vertical lines. Let me show you what it means to be opposite reciprocals. So remember, a reciprocal is a fraction flipped upside down. So for example, if I had the fraction 2/3, its reciprocal would be 3/2, but then it's going to have the opposite sign. And then the theorem states that if I were to multiply these 2 fractions together, their product is going to give me -1. So 2 times -3 is -6/6, which simplifies to a -1. So just know that perpendicular lines have opposite signs and reciprocals. Let me show you how you might see it, and this is going to be coming up with slope-intercept form. So you might have remembered this formula, y equals mx plus b. This is what we're going to be using in the notes and in the homework today. So the m, again, remember, this is the slope. The b, this is my y-intercept. Now, to give you an example of 2 perpendicular lines, you could have y equals 2/3 x plus 1, and then the reciprocal with opposite signs, y equals -3/2, and then the y-intercept could be any number. Now, also remember that if you have a whole number, to make a whole number into a fraction, I can put a 1 underneath it. So when I want to flip this to its reciprocal, I can flip it very easily and then change the sign. So we have some sometimes, always, or nevers. So the first one, the slope of a vertical line is sometimes, always, or never 0. And this would be never, because remember the slope of a vertical line is undefined. The slope of a horizontal line is sometimes, always, or never 0. Always. The slope of a line that rises to the right is positive. Always. And then the last one, the slope of a line that falls to the right is always negative. So the next example wants us to find the slope of the line through the 2 points that are named. So again, let's review the slope formula. Remember, it's y2 minus y1 over x2 minus x1. So what I'm going to do is this whole column here, I'm going to say that these are all my x1, y1 order pairs, and then this column will be my x2, y2. It doesn't matter which one you label as order pair number 1 and which one as order pair number 2. So now, be very careful with your integers. Watch your signs. So for the first one, I'm going to be doing 5 minus 4. I'm subtracting the y's over negative 4 minus negative 3. So however your middle school teacher taught you to subtract integers, that's what you're going to be doing here. The 5 minus 4 is obvious. It's a 1. But this denominator, this is really going to be negative 4 plus 3, so then this gives you negative 1. If your fraction can be reduced to a whole number, then do that. So this will simplify to negative 1. For part B, again, we're going to subtract the y's, so negative 2 minus negative 3 divided by negative 1 minus 6. Again, do your keep, flip, change or stay, change. That numerator will really be negative 2 plus 3. And then the denominator, if you want to think of it as negative 1 plus negative 6. And this gives me 1 over negative 7. Now, whenever you do this slope formula, if the numerator and the denominator both give you a negative number, remember, a negative divided by a negative is a positive. But in this case, the numerator is positive, the denominator is negative, so this is just a negative fraction. It's a negative slope. If you want to pull the negative sign out front, you can represent it that way as well. Then for C, again, I'm going to subtract the y's, so negative 4 minus negative 4 divided by negative 3 minus 8. Notice my y values here are both the same. When this occurs, this is going to be the graph of a horizontal line. Whenever the y's are the same, the graph of this line is going to just be y equals negative 4. But let's finish up doing the problem here. Negative 4 plus 4, and then this is negative 3 plus negative 8, 0 over negative 11. Remember, when the numerator has the 0, it simplifies to 0. So when the y's are the same, this is the graph of a horizontal line. And that slope always has a slope of 0. It's going through the y-axis at the negative 4. So this slope of this line would be 0, and the y-intercept, or the b, is going to be negative 4. Let's try the last one. So for part D here, again, I'm going to subtract the y's. So 9 minus negative 2, and then negative 6 minus negative 6. Notice this time my x's are the same. So this equation of the line is going to be x equals -6. This graph is going to be a vertical line. So if I do the subtraction in the numerator and in the denominator, I get 11 over 0. You need to recognize that when the zero's in the denominator, this slope is undefined. So the m here is undefined. This b, this y-intercept, would be none, because this is going to be a vertical line through -6. It will never touch the y-axis. So they want us to fill in this table, and they're telling us that R and S are parallel, but then R and T are perpendicular. So remember, for parallel lines, these are going to have the same slope. So R and S are going to have the same slope. However, for the perpendicular, these are going to have opposite signs, and they'll be reciprocals to each other. So opposite reciprocal. So for line A, straight across, since R and S are parallel, since R has a slope of -1/2, so does S. T, however, is perpendicular, so I need to change the sign, make it positive, and then flip the fraction upside down, and it simplifies to +2. For B, this time they're giving me T, so I need to make it opposite sign for R and S and make it reciprocal. So I'm going to flip it and make it negative. So -6, since S is parallel to R, R is also -6. For C, since they gave me S, I know R is exactly the same. It's going to be 1/5. And then for T, flip it and make it negative. For D, S and R are the same, so I'm just going to put -4 for R. And then for T, flip it and make it positive. Oops, I flipped it the wrong way. 1/4, and make it positive. Now, E has a letter, but it's the same idea. If you want to think of this as being A over 1, then when you go to write the reciprocal, flip it and make it negative. And then the same thing on the last one. Flip it and make it opposite sign. So remember, parallel lines have the same slope, perpendicular have opposite signs, and they're reciprocals. So for example 4, it says if R is parallel to S and R is a horizontal line, what is the slope of S? Well, I know that R and S are going to have the same slope, so as soon as I figure out that a horizontal line has a slope of 0, then that's what slope of S is going to be. So horizontal line always has a slope of 0, or you could also put it in as m equals 0. You're memorizing this, that the horizontal line has a slope of 0. The vertical line has a slope that is undefined, up and down. It says if K is perpendicular to N and N has a slope of 0, what is the slope of K? So let me go ahead and draw a coordinate plane here. Let me put my X and my Y axis. So it says N has a slope of 0. So that tells me that N is going to be a horizontal line. This has a slope of 0. It's horizontal. And I need to figure out what the slope of K would be if it's perpendicular. And vertical and perpendicular lines always form, vertical and horizontal lines always together form perpendicular lines. So the slope of K would be undefined. So remember, a vertical and a horizontal line together, when they intersect, will form perpendicular lines. Always. So the red line is undefined. Because if you think about it, the purple would be a 0 with a number, and then the red, the undefined, is going to be a number with a 0. Doesn't have to be the same number. What we're looking here is that it's the reciprocal, and when the 0 is in the numerator, it simplifies to 0, but when it's in the denominator, it's undefined, because you can't divide by 0. All right, so this is the equation for a line called slope-intercept form of a line. Y equals mx plus b, where the m in the formula is the slope, and the b is going to be your y-intercept. When we're graphing this, and you're going to be graphing it in the homework, you start at the beginning point, and from that b, that y-intercept, you move the slope, the rise and the run. Now, in order to find the slope in the y-intercept of an equation, you need to put it in that correct form first. So we need to take that first example and we need to solve it for y. So I need to rearrange the equation. So my first equation here, it's actually in a form called standard form. So what I need to do is I need to get this y all by itself. So I'm going to be subtracting 2x from both sides. And this leaves me negative 3y equals negative 2x plus 6. I can't add the 6 and the 2x because the 6 doesn't have an x. They're not like terms. And now I need to divide. I'm going to divide all three pieces by negative 3. And y equals negative divided by a negative, 2/3 x. And then finally, minus 2. So my slope is the 2/3. And my y-intercept is the negative 2. So for part A, your m is 2/3 and your y-intercept is negative 2. Now B is already rearranged for me. It's already in slope-intercept form. So my slope is the negative 1/4 and my y-intercept, my B, is the positive 2. So for part B, my slope is negative 1/4 and my y-intercept is positive 2. For part C, it's already solved for y, but remember, whenever you see y equals a number, this is going to be the graph of a horizontal line through negative 3. So my slope for a horizontal line is 0, and my y-intercept is going to be negative 3. Let me add an example here and show you x equals a number. So let me add a d here, and let's say it's x equals negative 1. Notice this one doesn't have a y. This is going to be the graph of a vertical line. Remember, the slope of a vertical line is undefined. And because this is just a line that's vertical through negative 1, the b here is none. It will never cross the y-axis. On the next slide, we're going to graph these four equations. You'll be graphing in the homework. Okay, so for the first one, I'm going to go ahead and graph my rearranged equation, and I'm going to graph it in red. So part A, that equation originally was 2x minus 3y equals 6. Remember, we rearranged it into y equals 2/3 x minus 2. So remember, this is where I start. This is my y-intercept. So I'm going to start at -2. And from that -2, I take my slope. I'm going to rise up 2, and then I'm going to run to the right 3. So from this point, I go up 2, and then to the right 3. And then I'll put my point. You can keep repeating this rise and run if you choose. I could still go up 2, 1, 2, 3, if you wanted to try to make a nice precise line. But for you guys with notability, it's nice because it makes a nice straight line for you. And then you would just connect. All you need, remember from chapter 1, to create or graph a line are 2 points. So you only have to do it one time from your original beginning. So this is A. This is the y equals 2/3 x minus 2. Next, I'm going to do B's equation, which was already rearranged for me, the -1/4 x plus 2. This time my beginning point is on +2. And notice my slope is negative. So my rise and run here, I'm going to go down for my rise 1 unit, and then I'm still going to move to the right. You could also go up and left, but I try to always keep one of my movements consistent. So if I go down 1 and then to the right 4, or I could go up 1 and to the left 4. Either way, you're going to get the graph of your negative slope, and notice it's falling from left to right. And then C was the equation y equals -3. Remember, it's the horizontal line that goes right through the y-axis at -3. And then that other one that I added was x equals -1, and this was that vertical line through -1. So you will be graphing in the homework. The next one wants me to write an equation of the line passing through the point -1, +1, that is parallel to the line with the equation y equals 2x minus 3. Remember, we just learned a theorem that stated that parallel lines have the same slope. So what I'm going to pull out of this equation only is the slope. So the slope I'm using, because my lines are parallel, is I'm going to be using +2. This is going to be the slope I use. The order pair that was given to me, this is going to be my x and my y. So what I need to do is take y equals mx plus b, and I'm going to replace the m with the 2. I'm going to replace the x with the 1, and then I'm going to replace the y with a +1. And I'm going to solve for b. So step number 1, step number 1 is to find the correct slope. Step number 2 is to replace these 3 numbers and solve for b. So I'm going to put 1 for the y, 2 for the slope, -1 for the x, and I don't know the b. I'm going to go ahead and multiply. I get -2, and then I add the 2. And the b of my equation, going through that order pair, that specific point, that will be parallel to y equals 2x minus 3, is going to be the equation. I now take y equals mx plus b again. I'm going to put in the same slope I just used and now replace the b with what I just figured out. So now the y and the x stay, but what comes out now is the m and the b. So 2x plus 3. And this would be your equation that is parallel to this one going through this order pair. Some of you might have also in your Algebra 1 course learned point slope, and you can use that if you're familiar with it. That formula is y minus y1 m times x minus x1. That's point slope. But all questions on the test will be left in slope-intercept form, so I'm going to just focus all of my examples just using slope-intercept, finding the b and then plugging everything else back in. The next example has lines perpendicular. Same thing, but now I have to change the slope to opposite sign and reciprocal. So perpendicular to this line, and notice it's not in y equals mx plus b form, so I got to fix it first. So subtract the 2x, and now it's in y equals mx plus b form. So right now, this slope is -2. I need to change this to the perpendicular slope, so I need to change the sign and flip it upside down. This will be the slope I'm using, and again, the order pair that I'm using is the 2, 3, and this will be my x, this could be my y, and now let's plug it in. Y equals mx plus b. Again, remember, this is your m. So I'm going to put in 3 for the y, 1/2 for the slope, 2 for the x, and I don't know the b. I'm going to multiply, and I get 1 plus b, move the 1, and my y-intercept, or my b, of the equation that's perpendicular going through the order pair 2, 3 is going to be the +2. So now I take y equals mx plus b, and this time just take out the m, take out the b. So y equals 1/2 x plus 2. And that is the equation that is perpendicular to the given equation and going through that order pair. All right, so here we go. This question wants us to find the distance from this point to this line. Remember, we learned that the distance from a point to a line is the perpendicular segment. So we need to find the equation of that perpendicular segment. So the first thing I'm going to do is find the slope of this line, which is -1. However, the slope of the perpendicular line is going to be +1. So now the next thing I have to do is I need to find the b. So just like we just did, I need to find the b of the perpendicular line. So I'm going to plug it in to y equals mx plus b. I'm using the purple slope there, and then I'm using this order pair for my x and my y. So I'm going to plug it in. 0 equals the slope, which is 1. And then I'll plug in the order pair 1. So let's see, let me do this in blue. And then this one could be the red. And I'm solving for b. So 0 equals 1 plus b. Move the 1. And the y-intercept of the equation that's perpendicular is now -1. So my equation that's perpendicular is going to be 1x minus 1. Because again, my slope here was a 1, and I don't have to put the 1 there. Now, what I need to do is, again, more algebra. I need to solve a system of equations. Now, if you have a nice, neat graph, you can graph these two equations and find the point of intersection. That's what I'm looking for. If not, you can use the method of substitution or elimination. I'm going to use substitution. So the two equations that I'm trying to find their point of intersection is the original given, y equals negative x plus 3, and y equals x minus 1. Because they're both set equal to y, I'm going to take what this y equals, which is this, and I'm going to substitute it into this equation for y. So I'm going to do negative x plus 3 is equal to x minus 1. I'm going to go ahead and combine my like terms. I could move the x this way or the other way. It doesn't matter. And then I'm going to move the 3. Negative 2x equals negative 4. Divide by negative 2. And the x of that point of intersection is positive 2. Now I need to find the y. So I'm just going to take this equation, plug in x equals 2, 2 minus 1, and the y of the ordered pair is 1. So my point of intersection is the ordered pair 2, 1. Now I can find the distance between the 2 points, and the other given ordered pair from the beginning was the 1, 0. Now I do the distance formula, x2 minus x1 squared, y2 minus y1 squared, all under the radical. This could be my x1, y1, x2, y2. It really doesn't matter. So now I'm going to subtract 1 minus 2 squared, 0 minus 1 squared, all under the radical, negative 1 squared, negative 1 squared, negative 1 squared is 1, 1 plus 1, and I get the square root of 2. On the test, you would leave it like this. This is exact, or also called simplest radical form. In the homework, they're going to probably say round to the 10th place. So the approximated answer is 1.4.